Yeah, now that we have the understanding where the operators are coming from, I think it would be nice to zoom in one aspect, and I'm sure my panelists that are coming up now, they would say it's the most important aspect. So with the open dialogue Defending the Future, the importance of security in Open RAN developments, I welcome the hosts and panelists on stage, please.
Nice music. Yeah, when I read the title, the importance of security, as you said, yes, I thought it reads like the importance of breathing for staying alive. We could say it's very important, and that's the answer, and let's have an early coffee break. We won't do that, of course. Yeah. So we have a packet drop, I believe. So Jean-Pierre didn't show up. So we have two panelists I'm very happy to have here with me on the stage, and I would like to introduce yourselves. Maybe Hannah, you go first, and then Carsten, please say why you're here.
Good afternoon, everyone. Thank you for staying for another day here in this room. I'm Hanna Bogucka from Rimedo Labs and from the Poznań University of Technology. I'm a university professor and an entrepreneur. We've started a spin-off from PUT, which is Rimedo Labs, and Rimedo Labs specializes in radio access networks, Open RAN with the applications and use cases. So nice to be here.
Okay, my name is Carsten Rossenhüffel. I'm CTO and co-founder of i14y, the European Advanced Networking Test Center. We're an independent test lab, and we are also a consortium partner of the i14y lab. And yeah, we've been active in security testing more for benchmarking than for actual, malware kind of testing for quite a few years. And now we see also the need and the opportunity to get active in Open RAN security.
So I'm very happy about this setup because it's the mixture I like. So we have academic perspective from Hannah, and Carsten earns his daily money with doing security. So I think this should make a nice dynamics for the upcoming couple of minutes. So the importance of security, let's start with a global question. You have to think security always in a holistic way because attackers have the tendency to find the weakest spot. So could I ask your view on the Open RAN system in general, and maybe singling out where we should focus our attention on? That could be an interface, like you are testing an i14y, but it could as well be sloppy password management of a software development in the second tier of a software supply chain. So please, could you comment on that?
Okay. So in my view, this, say, future networks, including the open future networks, like with the Open RAN, have several fields or surfaces of threats. They come from the field of typical, say, cybersecurity with the computer networks, computers themselves, cloud computing. From the openness, with the open air, with the open interfaces, and with the open RAN in general. From the ubiquitous nature of radio communication channel that theoretically everyone has the access to. And from intelligence, because the future networks are supposed to be intelligent. In particular, edge intelligence is envisioned. So this intelligence, of course, provides some opportunities, but also challenges. So maybe I could stop here, but in general, it is not. It is the security issues, the security topic for Open RAN for the future networks combines all these fields, and all have to be considered together, since it is not just about the privacy. Yeah, the password protects more or less, yeah, the privacy of communication or storage or processing. But there are a lot of other possibilities for this malicious action to jeopardize the network in other ways. So let me stop here. I hope there will be a chance to extend this.
Right. So first, I think the attack surface doesn't necessarily increase greatly with Open RAN. It just changes, and people need to get used to it. So that's maybe a very, very generic view. But my day-to-day experience is that it's often the trivial mistakes that people make. For example, the sloppy passwords or the port that is still open. I still remember, it has nothing to do with Open RAN, but this port for CPE management being open in the Deutsche Telekom DSL network worldwide, and then some attacker finding it at some point and exploiting it, which brought down most of the CPE DSL routers in all consumers in Germany for a day. So this can quickly happen, and this was a really trivial mistake, right? We don't have to look for advanced AI stuff. Of course, we should also do that, but we first have to start with the trivial things. Not only harden the passwords, make sure that access links that are in the public, that they are encrypted, make sure that the basic well-known exploits are not possible, things like that.
Okay, yeah. So Hannah mentioned this already briefly, but I want to come back to that. The intuitive approach is if you open things up, like disintegration or open interfaces, Open RAN, then you open it up also for attackers. That's the intuitive reaction you have. But you say that doesn't necessarily increases the risk because it's also opened up for surveillance. So could you comment on the openness as a security angle of?
Yeah, so maybe I'll start with that. So yeah, we've always tested open interfaces. I mean, in the wireline industry, all of the protocols are open and well known, and firewalls in the wireline industry, they also need to operate under well-known parameters. So all of the facts, how they are running, are open. And from my point of view, from my experience, it's more of a risk if the vendors try to keep things close and under the hood, because then it's not possible to test independently if security problems exist and how to mitigate them, right? And for example, right now we're still in an early stage in Open RAN. I think it would be good if more test campaigns would already integrate security testing. We haven't done that so far in the Plugfest, and when we try to convince the vendors to go there, of course they are all a little bit careful, right? And it would certainly be good to follow these paradigms that the industry is always voicing. Security needs to be a design criteria. It shouldn't be some afterthought in the end, right? And I would love to work in the i14y lab and in other contexts to make this happen again.
Good.
Yeah, I think this openness has some challenges, but most of all, it has opportunities, because first of all, it provides transparency for the service, for the equipment providers, for the service providers also, that this transparency, this openness allows to create some new methods for security that can be applied easily and with a very short time to market, which is very important in Open RAN. And secondly, I think that yes, when you have the open interfaces, you will have the access to some parameters that can be utilized for X apps and R apps that are then developed specially for the security handling, yeah, for whether it is the detection or analysis of the threats and various kinds of attacks, and also to mitigate the attacks or eliminate the malicious users or the attackers.
That was a very nice bridge, actually, because when we were preparing this, we were talking about or an architecture, and the special role of the RIG as a platform for possible potential security services, also for data sampling and having possibly faster reaction time. So could you elaborate a little bit on the RIG as a potential accelerator for security services?
Yeah, it's an intelligent controller, so you can apply all these XApps or RApps that intelligently handle also the security issues. The application of AI for the anomaly detection is well known. Now this can be closer to the end user because Open RAN can be very close to UE and DU and CU. So it's a good opportunity because, for example, there are several kinds of threats like jamming, for example, or signaling storm, or denial of service, distributed denial of service that can be detected only in place when they show up. I mean, very close to the end user. Yeah, so this creates a lot of opportunities, and we actually have already some use cases for this, some tested use cases. And I think it's good. It's very important to have this opportunity closer to the place where the threats, that attacks actually occur. So this is important. Yeah, I think that's what I wanted.
Carsten, comments on the RIG as a host for security?
Yeah, I think it's a fascinating proposal. And I agree, from the design perspective, it would be a right place to do intrusion detection, intrusion prevention, to, for example, cut off malicious UE or whatever could be happening. Of course, from the practical side of a tester, I look forward to seeing these implementations, and I think it's still some way to go until we can rely on the necessary interfaces to implement this use case with any Open RAN infrastructure out there. But sure, I think it could be beneficial.
Okay, follow-up question on that. So in a situation where you could envisage a compromised XOR app, then a neighboring security app obviously wouldn't have the right to do anything about that. So could you find a solution for that?
Yeah, I could say, yeah, okay. When you apply the machine learning or artificial intelligence in general for anomaly detection, for example, then the computer scientists have elaborated on this kind of adversarial machine learning methods that where the attacker is not just a simple attacker, but the attacker is also intelligent and also has some algorithm to jeopardize the other machine learning algorithm to learn well, not correctly, like by poisoning data or by introductions of some malicious examples to learn in the other direction that the algorithm should. So then, what the security algorithm can do or should do is to detect that somebody tries to jeopardize this algorithm, and there are these two intelligences that play against each other, and this has been actually researched within the game theory to show that. At the end, this game ends up at some equilibrium. So this is a problem that is well known, but of course we are not, we cannot totally defend from this. Yeah, but in fact, it's something to be handled on both sides. Yeah?
Okay, Carsten, you want to comment? Game theory is a little away from your bread and butter.
No, I always appreciate the idea from the academic side. It's fascinating, and certainly we always need to think ahead of the attackers, right? So it's good to explore the theoretical approaches. Whether in practice it will be possible that one XApp controls the other XApps, whether they have been undermined by malicious attackers, that's probably a little bit science fiction, I think.
Okay.
So I was more thinking about having an XApp an XApp to actually look at the UE behavior or at the RU behavior, right? Because for me, a common scenario would be the UEs can easily be taken over, and even an RU, it's pretty easy to climb up a mast and disconnect the Ethernet cable and plug in your own stuff. And if it's not encrypted, from the communications point of view, it's quite easy to take over a cell site. Theoretically, right? In practice, it will be more difficult, but that would be a more common attack vector that I could see.
Yeah. Okay, so climbing down a little from academic fancy to the real world and what you experience every day, could you tell us about the testing reality in the lab? So what is it you're faced with when you do your job in i14y?
Right, so I think there are a couple of interfaces that we need to verify. So one is the management interface, of course, and the management interface, that's, you know, the most basic stuff is passwords. If they use passwords, it's like, can you access it without password? If you connect directly to the radio unit, for example, all of the basics. And I mean, other tests in operators, even outside Open RAN, have shown that this basic management level access, even for routers, you know, established equipment, is often difficult. It has some easy exploits if you don't test it. That's number one. And then what's kind of new is the control plane between the RU and the DU, like the open front hall. And that communication needs to be encrypted, so we need to test that. We need to make sure there are no attack vectors possible by sending a lot of data on the control plane, by trying to get in with fuzziness testing. That's probably what Jean-Pierre's area of expertise would have been. If you don't know what you're looking for, then you just randomize the testing and you search in the blind, you know, blindfolded. And when you see the device reacting, for example, the CPU load going up, and you don't exactly know why, but you seemingly have found some patterns in the control plane, then you continue to exploit there. And that's called fuzziness testing. And that's particularly important for areas where you don't know the exploits yet. So in the firewall space, in normal network security testing, we just go to the NIST database with thousands of CVEs, attack vectors that have been accumulated over the years, and we just test all of them through, like thousands of test cases in an automated fashion, and that, you know, covers most of the attacks. But in Open RAN, probably they are not known yet.
Hannah, you want to comment on the comprehensiveness of the search as has been?
Yeah, I wanted to say that, okay, apart from this high above the ground considerations on artificial intelligence and so on, there is a lot of threats that are very simple and easy to be done, easy to be fired. Like, for example, jamming, the old well-known jamming. That you cannot encrypt against that. You just have to handle it somehow. The good news is that it is not computationally, but energy costly to fire out such attack. And then the attackers sometimes change the bandwidth, and we can react to change the bandwidth as well, or stop transmitting and start again when the jamming is stopped from this particular band. Another example is this denial of service, when the attacker tries to occupy as many resources, and this attacker can be an authorized user, like you buy the telephone from the market and with the prepaid card, and you can do it. And of course, this happens. And now the good news is again that in XApp, quite fast, you know, with below 1 millisecond, you can detect the anomaly in this case. Yeah, and even in some cases remove these malicious users. Or a very simple attack is to activate the the users or the devices in the Internet of Things, where a lot of devices are battery powered, so they are very sensitive to, being awake and starting being active, like transmit something or do something without the need, because the battery is exhausted, and so forth and so on. So it's there is a lot. I mean, there is a big need to find algorithms and ways to prevent this, and in a timely manner. I mean, within the particular period of time, to prevent the attack, and closer to the end user, as I said before.
Yeah, but that's an important thought. It's not only about protecting the network. It's also about protecting the users, the UEs and the applications. And I think that's what we see in other networks, like in wireline as well. I spoke about DSL earlier. Now, for many operators, it's not only about protecting their own network against attacks, it's also to protect the consumers against attacks that are coming from outside to the DSL CPEs. And in the same way, I think, especially in IoT, this is going to become more important, because if you attack an IoT device successfully, it drains its battery, fine. But maybe the consequence of it is it reports the wrong values or no values, and that again leads to a certain behavior that can even destroy devices in the end. So without exploiting that too much. And the other thing about the S-plane, synchronization plane, also important point. I mean, at the NTC we've tested synchronization for 15 years now, and there are some devices that can actually protect against these jamming attacks actively, but there is still a big lack of insight in many networks, like where does the jamming actually occur and what are the jamming patterns. There was a German research project 2 or 3 years ago that tried to figure out like where is GPS jamming actually happening. Mostly it's truck drivers driving around and trying to prevent their employer from finding out where they're driving, so they're jamming the GPS around. Actually, that's the case, but there are also obviously some more professional attackers, and it's good to understand where does the jamming happen and which cell sites are affected. And obviously, the more small cells we will have, the more cell sites that are just above our heads and not on big towers, the easier it will be to do jamming, right? So we need to protect more, and we need to understand the patterns more, and maybe we need to track down the attackers more aggressively.
Okay, thanks. So time's almost up, so let me ask one last question, a little bit speculative again. So you mentioned the word prevent, and you can prevent against known attacks. That might be possible, but can you envisage a situation, I just say the word attack graphs, where you can harden your system against the attacks even the attackers haven't thought of yet? So that's a bit complicated question, but could you just give some outlook on that, and then we close it?
Yeah, here again, AI is playing a role, because apart from learning the situation, you can do the prediction. So obviously, yes, I think in general, that's.
We should collaborate on that, Carsten.
Yeah, that's what quite a number of firewall vendors are already doing. They're kind of sandboxing anomalous behavior, and I think that's the way to go. Not to look for something that but to also look for these zero-day attacks and to understand like when does something not work as normally expected, and then we need to sandbox it and try to analyze it more closely.
Yeah. Thanks a lot to the two of you. So to Hannah and Carsten, I think we have convinced you that it's really important, security. Yeah? Thanks.
Thank you.
Thank you.